robotics is basically a discipline or a practice or an activity that involves controlling the actions of a machine. And it includes programming the machines using sensors that they have so they can operate by themselves within an environment by reacting to things that take place in an environment. Well, the machine is going to have sensors on it and be able to move. And the way we control the machine is by programming. And one thing that distinguishes a robot, say, from some other type of machine is that the robot can act on its own. It can make some of its own decisions. The whole notion of recreational robotics is to take this complexity and excitement of robotics, the discipline. As we take the challenge of robotics, which is really a multidisciplinary approach to getting machines to do different actions, and we bring it down to a level where children can actually participate and build and program the robots in what they consider to be a fun activity. Okay, so let's go a little deeper into what is actually STEM. STEM is an acronym, and it's getting to be a buzzword: science, technology, engineering, and mathematics. What's important to do when you're engaging in a STEM activity is to really be true to those 4 different disciplines and really look at what you're doing and say, well, is this just technology, or is this just science? And it's really the fusion of those 4 disciplines into kind of a seamless whole. So robotics is a great example of this because you have the technology, which is the unit itself, which is built in. You also have the computer programming aspect of this, another technical aspect. The mathematics is figuring out, how to get the robot to move a certain distance. So let's say we need the robot to move a certain distance down the table, perform some action, and come back. The simple task of getting a robot to move a very specific distance is quite challenging. So we can use mathematics in that by doing things like calculating the circumference of the circle and how far will a robot move forward when its wheel turns on one rotation. And then if you have to get a certain distance, you're going to have to do more than one rotation. So there you can start doing an experiment where you keep data and you can say, how far did the robot move in one rotation? And you record that. Then you say 2 rotations, you record that, and so on. So you gather some data and you can kind of compare the data of how far the robot actually moved per rotation, knowing the circumference of the wheel. And then you can see if you're actually arriving at things like the equation for the circumference of the circle, and see if mathematically your data, which is your science part, corresponds with the math theory, which is basically, in this case, the concept of the circumference of the circle being pi times the diameter. So it takes a very abstract concept, mathematical concept for most young people especially, but I think even for adults like pi, and it puts it into the real world. And if it's part of a challenge where they're trying to compete against their fellow classmates or another team, it gives them a real great reason to understand something. Okay? The whole point of this is to get young people excited about math and science. They're automatically excited about technology. That's not difficult to give any child a PlayStation or an Xbox. They're technology, smartphones, that's not hard to get children excited about that. The math and the science is a different challenge. When you can show them that they can have the type of experience which they had is fun. And you say, if you wanted to be an engineer or a scientist, this is what you could do every day on your job. You're giving students a different type of motivation, so when they sit in that math class, which I sometimes consider like eating your spinach, you need to sit in math and do the dull part of learning math. We're trying to give students is the motivation for why they would want to learn math. And I think the next step up, I think science is a little more interesting than just pure math. What it's the same idea. Why are you sitting in a science class listening to the instructors go on and on? It's because you can apply that into your career and do something that you'll find exciting and enjoyable and make a significant contribution. Well, if you want to launch your child onto a career that utilizes math and science and is very relevant to the world, not only today's economy, but the economy of tomorrow. If you think about the jobs that are going to be around, if a child of 9 years old can program a robot, imagine what's going on in terms of a lot of jobs that are going to be replaced by machines to a greater and greater extent. If you have the skill to tell machines what to do, and you can troubleshoot systems when they break down, if you have those advanced degrees in math and science, you're going to be very relevant in the jobs and the economy of tomorrow.